In this video, I'm going to explain this cyclic codes, how the cyclic code encoder it works. Okay, so now we'll take one example here. Design an encoder for a 7, 4 binary cyclic code generated by a generator polynomial 1 plus x cube and verify its operation for the message vector 1011. Means for this given uh, the problem definition, we have to write the encoder here. Okay, so we have to write an encoder for this 7 comma 4. This 7 is the n, okay, means number of coded messages, and 4 is the number of bits of the 4 bits message here. This is the 7 bits encoded message, and this is the your 4-bit message. And 7 minus 4 is the 3. 3 bits are going to be added here. Okay, uh, means how to draw the encoder. This is the general form of an encoder. Here how it is written here: r naught, r1, r2, like rn minus k minus 1. And look at this here: r naught have a one connection, g naught, g1, g2, like gn minus k minus 1. And uh, how many registers actually required, so that how many register required, that will be depends upon the given n and k value. In this case, n value is 7 and k value is 4. Means 7 minus 4 means needs a 3 registers here. Okay, means number of register requirement is based on a given this n and k value. Yeah, R naught. And numbering also R minus R subscript n minus k minus 1. Means R naught like R1, R2. In this case, it is a R naught, R1, R2. Means every output of this register is XORed here with a coefficient G1. Again, R1, we have a 1 coefficient here. It is a G2. Like, okay, it will goes. And here the operation is like that. The last output of the register is XORed with the input here. Okay. How this connection, the last output of this register is XORed with the input message. This is the input message, means where we are giving the input is given to this XOR here, this XOR gate. And there is an enable gate here. It's going to be enables here. Okay, the meaning of the enable here, once it is enabled, the input message will be, means the whatever the messages are coming here, means after XR, they are going to be enter into this circuitry. Yeah, for example, in this given case, the generator polynomial is 1 plus x cube, 1 plus x cube. In terms of generator polynomial, g0 plus g1x plus g2x square plus g3x cube here. And g0, yeah, there is a 1 plus x cube, and the coefficient of this is 1. And a g1 coefficient, x coefficient g1 is 1. And coming to this x square, that is g2, it is a 0, no connection. And last is a x cube, means that this is the last one. Yeah, so based on this, now we will draw the encoder. Yeah, g0 1, g1 1, g2 is 0. Yeah, number of registers are 3 registers, R0, R1, R2, and there is a connection here from this, and XOR gate, one connection is there, and G2, it is 0. Yeah, there is no connection here. And lastly, we have a R2 here. First, how to draw? How many registers are required? 3 registers are required. How many XOR gates are here? Because G1 is here and G2 is missing. So 0 here, there is no XOR gate here. R2 is output directly XORed here. Okay. What is the message here? It is a 1011. Means every time this one bit will be goes on enter into this circuitry. Yeah. Then what is the coded message here? Okay. How the it will be encoded here. Okay. When the gate is opened, whatever the input we are given, so that will be enter into this circuitry through XOR gate. And also this will comes out from the output. Means once it is 1 is entered, the output also coming out here. Next 1 will be entered and output will be. Next 0 will be entered into the circuit. That same output will comes out here. Last bit is 1 that will be entered into the circuit, and that's also comes out of the this coder here. Then what is the encoded message? How it is going to be encoded? Now we will see the operation of this encoder. Yeah, and we will prepare one table such that how many rows and how many columns are required. So number of columns, look at this. Registers, how many registers are there? Three registers. Means this side is a three columns. What is the input we are given? 1011 here. Okay. 1011. What is the message here? 101. This is the rightmost bit. So that will be entered here. Means 110. Means a number of columns required. Means how many columns are, how many rows required. The number of rows depends upon the message length. In this case, number of bits of message is 4. So that's why 1, 2, 3, 4. This is, what is this? This row? This is this row initially the content of the registers are 000. Yeah. Now we'll see the operation. When the first bit 1 enters here, 1 enters here. Earlier, all the content of the registers are 0. 1, the content of the register, these two are XOR. 1 plus 0 XOR, that will comes here. And this directly comes, okay, and stored in a register R0. And coming to the R1, the content of the R0 and this the coming, okay, whatever the output coming here, that is 1. 1 plus 0, 1. So that's why 1, 1. And what about the R2? R2, the previous content of the R1 simply shifts to the R2. Yeah, the previous content is 0. Yeah. So I mean, similarly, we can easily write the content of the register. What is the previous content like? What is the content of the R1? Yeah. Only thing is we have to what is the content of the register R0 and R1 for every input. Next bit is 1. So when it is a 1 and the content of the register R2, it is a 0. 1 plus 0, it is a 1. So that will comes here and will be stored in a R0. And the previous content of the R0, okay, here in this case 1. 1 plus present input is 1. These two, 1 plus 1, it is a 0, that is a R1. It is a 1, 0. What about the R2? It is simply shifts here. So next is the bit 0. Next is the bit 0 here. This is the input I am given. And the previous content of the R2 is 1. 0 plus 1. Again, it is a 1. Yes, that will be stored here. What is the previous content of the R1? Previous content of the R1 is 1 here. Means 1 plus 1, it is a 0. That's why 1, 0. What about the R2? Simply it shifts here. So next input is a 1 here. Next input is 1. When 1 comes here, means there is the last bit 1. The content of the this R2 1 here, the content of the previous R2 0. 1 plus 0, it is a 1. So that will be stored here into the register R0. What about the previous content of the R0? Previous content of the R0 is 1. Present is also 1. So it is comes from this 1 plus 1, it is a 0. So in this way it works. When the last bit 1 enters, at that time, what is the content of the register? The content of the register is 100. There is a 10. Then the given message is 1011 and the content of the register is 100. So once it is fully loaded, then the gate is closed. So another 3 clocks are required to shift this contents here. Okay. Once it is all the messages are entered into the circuit, this gate is closed and the content of this will be simply shifted here. That is a 100. In this way, this works.